Thanks very much, everyone. Thanks for sticking around as well. I know it's been a huge day, and the pub's calling to us all. I know it's calling to me. My name's Justin. I'm the head of the head of research at Tanto Security, a research-driven security assessment firm where the work is mysterious and important. And I like making computers do weird things. And when I'm not making them do weird things, I'm normally thinking about making them do weird things. And I want to share a story with you today and take you on a bit of a journey. And there's this thread throughout it of luck. I feel like I was really fortunate in many ways while working through the story I'm about to share. I felt like I was the right person in the right place at the right time, trying the right weird thing. But I think there's also things you can do to increase what some call your luck surface area. And we'll talk about that at the end. So it's a story from the vaults. It was around about the end of 2019. And there was like a vulnerability of some sort. I think it was in like UEFI or Thunderbolt. And I wanted to get my machine patched for it. I was running Debian old stable at the time, so the version before the version that was currently the latest. And it was still supported, it was still getting security updates, but some of the packages were getting a bit stale. I Googled around, and to update firmware, it seemed like I needed something called firmware update, which makes sense. Firmware update is the client-side utility of something called the LVFS, or the Linux Vendor Firmware Service. So firmware update acts as a client to download firmware updates from LVFS and flash them to your machine. For those who are unaware, firmware is kind of like the software that runs on your hardware, which sounds confusing, but think of something like a wireless mouse dongle. It's got its own code running on it to manage things like the radio and to manage communications with the computer. That software can be updated if there's performance problems with it, or performance improvements, or a security bug, and you want a firmware update in that kind of case. So that's the kind of sphere we're playing in. So I wanted firmware update so I could update my machine for this latest bug. And because I'm apparently allergic to the GUI on my Linux workstation when I use my Linux machines, I dropped to a shell and I installed firmware update. And then I did a firmware update manager refresh. And I'm going to say this quite a few times throughout this talk, but firmware update is very similar to apt or apt-get if you've used Debian or Ubuntu. And firmware update manager refresh is similar to your apt-get update. What it's doing is it's downloading from LVFS the available software or the available firmware for the devices you've currently got plugged in. So I did a refresh to kind of update my catalog, and I got an error saying that there was a problem finding a file in a particular S3 bucket. And because I'm a curious person, I whacked that URL into curl and got back an error saying that the bucket did not exist, which was interesting. Because it turns out about a year and a bit prior, beginning of 2018, firmware update had shipped an update to the config file that stopped pointing clients directly at the S3 bucket and instead pointed them at a DNS host name controlled by firmware update. And the commit message said that the reason for doing this was to give them flexibility so that in the future they could maybe move away from S3 and host their CDN somewhere else. It seems as though they had implemented that flexibility and then taken advantage of it and indeed moved their CDN away from S3 and onto somewhere else. My problem was I was still running Debian old stable, which was shipping an old version of firmware update that didn't have this change, and LVFS must have deleted the S3 bucket once they did their migration. And the problem with deleting an S3 bucket, there's many things in the cloud that can become what's called dangling. Whether it's a subdomain or whether it's an S3 bucket, Amazon's not shy. If you delete an S3 bucket, someone else can take the name. Like they say that in the guide for how to delete a bucket. And I struggled with this for a few weeks or a few months. I was thinking, like, is it the right thing to do to register a bucket that belonged to an open source project once upon a time, that my machine was still pointing at for software updates? You know, this project doesn't have a bug bounty program or a VDP. Is registering it the right thing to do? Like, I would never exploit something like a SQL injection or an IDOR vulnerability if there wasn't, explicit permission, or if I did it, I wouldn't admit to it. So I struggled with this idea for some time, like, should I register the bucket? And eventually I thought, what's the worst that could happen? It only affects old versions of firmware update. How many people could possibly be running old versions of firmware update? And beyond that, how many people could actually be trying to use it on a regular basis? What's the worst that could happen? This is foreshadowing. So I registered it right before bed, turned on the logs, went to sleep, and woke up the next morning to 41,000 requests overnight. Turns out there are still some people running old versions of firmware update. But also, people who aren't psychopaths and actually run a GUI on their machine, like GNOME or whatnot, who run the GNOME Software Center, it triggers firmware update once a day if it's installed. Oops. So once I calmed down, I estimate that there were about 100,000 Linux machines phoning home to this bucket still. If we wanted to do something with this, what could we do? At this point, we're like the dog that caught the car. What could we do with control over this bucket? This is the right time to probably say, I never did anything with the bucket. It always stayed empty. So LVFS. It contains firmware.xml.gz. And this is kind of like a manifest or a description of the entire catalog of available firmwares. And alongside that sits a signature in the bucket, signed by a key that we don't have. The XML file describes all the different devices that can have their firmware updated through downloading updates through LVFS. Each one of those points at the actual firmware file, which might be in the S3 bucket, or it could be on the vendor website, I think, for all firmware update cares. But what's critical is each entry in this firmware catalog has a cryptographic hash. So the hash of the actual file, the firmware file, is in that XML file. So if someone was to do switcheroo on one of those firmware files, the hash won't match anymore, and there'll be a signature error when you try to download it and install it. But we can control the XML, so we could just swap out the hash in the XML for the hash of the file that we put there, but then the signature will break. So you've got this chain of integrity. The XML is signed, and then the XML has hashes of the files. It's very similar, again, to Debian's apt. In fact, I'm pretty sure firmware update and LVFS probably took inspiration from Debian when building this kind of chain of integrity. We can control the XML, we can control the signature, but we don't know the key. One more thing, it's a PGP signature, and there's something about PGP signatures that will become important shortly. There's the idea of normal signatures, or I call them attached signatures to give a bit of contrast, to a detached signature. So an attached signature is a single file that has the document that's been signed or the data that's been signed with the signature in the file itself. A detached signature is two separate files. You've got the original file, then you've got the signature produced separately. LVFS uses the detached signature pattern, just to kind of make that clear before we start playing with PGP too much. So what do we want? Being in control of that bucket, we'd probably need to find a bug in firmware update that's on either the left-hand side of the signature validation or during the signature validation. If there's a bug on the right-hand side, we probably can't get there without having the key to create those signatures. And a complete bypass of the code signing thing, the chain of integrity, would be awesome. So let's explore how firmware update works in a few different ways. The first one is when there is a good, legit signature. This is how the program is meant to normally work. You do firmware update manager refresh, and you get refreshed. It's kind of boring, but that's what we're supposed to be seeing. What if we swap that good signature that's detached for a bad signature that's detached? What if we just signed a signature with our own personal PGP key, for example? So we can't afford to go fiddling with the real S3 bucket. We've got 100,000 new friends phoning home to it. But the cool thing is, firmware update has a local config file, so we can point that URL at our own server to kind of do some testing. It's actually the file that got changed back in early 2018. So we can point it at localhost or something on our local area network to kind of simulate different situations. So the first situation I simulated was that bad detached signature. So we can control the XML, And I made the decision to put some XML that would intentionally throw a parsing error, with the idea being either we're going to see a signature error or an XML parsing error. If it's a signature error, we failed on the left-hand side of the signature check. If we get through to an XML parser error, we've probably bypassed the signature checking altogether. So here's an XML document that's going to intentionally throw an error. We create a detached signature with our personal PGP key that firmware update doesn't know about, doesn't trust, doesn't care. We serve the XML that's going to throw the error and the signature over HTTP, and we try and do a refresh. And we should expect to see a signature error, which we do. Firmware update doesn't love the signature that we created. So that makes sense, that's expected. So that's the bad detached signature. I thought about it for a bit and thought, what would be something weird we could throw at firmware update? What about a bad attached signature? Again, we'll just use our own PGP key, but rather than being a detached signature of the XML, we'll make it an attached signature of the XML, or just any data, really. And you can kind of tell by the picture, it's a weird situation. You've got a document that's signed by a document with its own signature. It doesn't make sense. It's not supposed to. So again, we've got our weird XML that will throw an error if it gets parsed. And we sign the word lol with our own personal PGP key and put it in the file that normally represents a detached signature. We serve it up, we do the refresh, and we should expect to see, again, a signature validation error. But we see an XML parsing error, which is weird. Swapping out the detached signature for an attached signature magically bypasses signature checking somehow. We can now control the XML file. We can bypass the signature checking. We're now in control of the firmware updates for like 100,000 Linux machines, which I think is pretty cool. But why does this work? This took me longer to figure out why it worked than it thought of to think of the stupid idea in the first place. So here's what the source code for firmware updates signature validation looked like in early 2020, and don't panic, we'll walk through this bit by bit. It boils down to roughly 3 parts. Cryptographically validate the signature, like mathematically, pull the result of that validation out, and then make sense of it and interpret it. So 3 different parts. We'll zoom in on the first 2 parts first. So all throughout this, we see references to something called GPG-ME, which is GNU-PG made easy. And it's a C library actually from the GNU-PG project for C developers to integrate with the GPG world. So we're using GPG-ME verify to verify SIG and data. SIG is the signature, which is detached or attached in our case, and data is the document that was signed. Verify the signature. If that signature validation fails, just bail out early. Bad signature, go to bad. But if that succeeds, we then extract the result out of that validation operation, stick it in a result structure. Again, if that fails, go to fail. That's that first part. The second part, what we're doing is looping over each of the signatures that were extracted out of that verification operation. And for each of those signatures, if any of them are bad, return an error, else we make it to the bottom through the loop. We've survived the entire gauntlet, return OK. So again, cryptographically validate the signature, extract the result, loop over the signatures, because a signature can have multiple signatures in it, which is kind of weird, but it makes sense in the PGP world. For each of the signatures, there's probably just one. If it's bad, go to fail, otherwise fall through to looks good to me. But it's weird that we're not checking to see if any of the signatures are good. We're checking to see that none of them are bad, which is a strange inversion of logic. So in the happy case, where you've got a real update bundle from the real LVFS with a real good detached signature, the validation succeeds, the extraction succeeds, loop over the signatures, there's probably just one of them. It's not bad, so don't bail out, must be good. For the bad detached signature, the one where we created our own detached signature with our own key, the mathematical validation works fine. We extract the result fine, but the one signature in there is bad, so we return bad. So those two kind of make sense. The good detached signature falls through to the bottom. The bad detached signature gets spiked in that loop. But what about that weird case where we've got the document and then with an attached signature on the side? What's happening in this code logic for that case? We start with the verify. And if we zoom in on this, this is a kind of snippet from the documentation of GPG ME. So SIG is our signature. In this weird case, it's the attached signature of the word lol. Signed text is the document, the XML file, and plain is being set to null by firmware update. GPG says, this function verifies the signature is valid. Makes sense. But there's two different ways you can call it. If the SIG is a detached signature, which is the normal case, the happy case for firmware update, then the signed text should be in signed text and plain should be null. That's the way this function's meant to be called, but we're causing it to be called with an attached signature, so it doesn't apply to us. Otherwise, if signature is normal, which is the attached signature, so this applies to us, signed text should be null, but it's not. And plain should be a writable data object, which it's not. It's null. So neither of the prescribed uses of this function apply to the case where the attacker can control the signature and kind of cause that mismatch, which is kind of the job of signature checking functions, is to defend against the case where an attacker can control the signature. So if none of these cases apply to us with this weird usage, what's going to happen with the verify? It's going to succeed. Okay, it succeeds, cool. Well, then we do the extraction. Maybe this is where GPG is going to be like, you called me weird, I'm going to not let you extract it. No, the extraction of the result succeeds. So then we're going to loop over all the signatures that were extracted from the verification. To understand what's going to happen in this loop, we need to look at what the result structures look like that may be extracted in the different cases. So in the happy path, the good signature, and in the unhappy path of the bad detached signature, the structures look like this, left-hand side, right-hand side. The signatures field is a pointer to a linked list, pointing to a single thing in each case. On the left-hand side, it's a good signature. On the right-hand side, it's a bad signature. Makes sense. But what does the result structure look like for that weird third edge case where it's data that was signed by an attached signature of the word lol? What does that structure look like? It looks like this. Something look weird? There are no signatures in the result. The signature validation succeeded, but there's no signatures in the result. So when we go to loop over them, we skip the loop because there's no signatures to loop over. And we fall through to, I don't know, looks good to me. So firmware update, it certainly had some kind of questionable design to it. It was going to be like, well, we're going to assume that if those first two steps, the verification and the extraction, succeeded, then there's going to be some signatures for us to loop over, but that's not a valid assumption, it turns out. Checking to see that there's no bad signatures is definitely fragile logic. It would be much safer to check to make sure there's at least one good signature. We were able to cause the weird edge case to have 0 signatures bypassing the loop. The fix for this, for the firmware update project, was the kind of really hacky fix I suggested to at least break my proof of concept, which is to just bail out if there's no signatures in the loop, and that breaks my attack. I think it would be prudent, and I did mention to firmware update, you should probably swap the logic around and check to make sure there's at least one good signature. I'm not sure if they've taken that on board yet. But then there's GNU PG with their questionable design as well. I think it's surprising for the verify and the extraction to succeed, but have 0 signatures that it actually checked. So I emailed them and said, I don't know if I'm holding it wrong or if firmware update's holding it wrong. Firmware update's holding it weird, but this feels like a fragile design that's really easy to mess up with, and I really like safe APIs that are really hard to mess up with. And they got back to me and said, no, this is working as we expect it to do. It's intended design that you can get back 0 signatures in a list. So I'm like, okay, cool, fair enough. So I held onto that bucket for about 30 days before I gave it back to the LVFS project. Here's some pretty numbers. You can see that at its peak, there were almost 12,000 people, actually. Bang on 12,000 people hitting it per hour. You can kind of see this beautiful time zone, different people waking up different hours of the day pattern. You can see people don't like turning their computers on the weekend, weirdos. But we were getting like 100,000 hits per day, which is why I estimate that there's probably at least 100,000 people who are running this. So I took this all the way through to actually returning XML that represented a device that was installed on my machine. And lo and behold, GNOME Software Center with the signature bypass, again, not in the real bucket, just in the lab, said that I've got an update, a firmware update for my machine. And you'll notice it says in red, device cannot be used during update. I didn't click install, because then the device probably wouldn't be able to be used after the update either. And I think there's also protections for different devices. I think some devices have their own end-to-end signatures, like a mouse dongle may do its own signature check to make sure that the firmware was built by the manufacturer. I'm not that much of a hardware person, but I figure that LVFS and firmware update had this signature architecture for a reason, and so bypassing it definitely felt significant to me. If you want to read the full clinical story of how I found this a couple of years ago, it's on my GitHub in my advisories repo. And at the same time, check out the TantoSec blog. We've got some cool stuff in the works that we can't wait to share with you, so keep an eye on the Tanto blog as well. But like I said, I feel like there was this real thread of luck throughout this. I felt like I was the right person at the right time, noticing this dangling bucket, grabbing it. Interesting decision, but it did it anyway. And then the first weird PGP thing I thought to throw at it worked magically. So I got really, really lucky. But I'm still really proud of the work I did, especially with taking it to ground in the root cause analysis. But I also think that there's things you can do to make yourself get more lucky, or to increase your luck surface area. You know, getting struck by lightning is pretty rare. But if you wanted to, you would go to a mountaintop and hold a really long piece of iron to make yourself more likely to get hit by lightning. So how can you make yourself be more ready to have luck come your way? For me, it was probably being allergic to the GUI and doing all my stuff in the shell, so I'm exposed to more error messages in the tools that many people use, maybe just using my computer in a bit of a different way. And then there's my flight hours as well, struggling and battling with PGP in a past life, making me aware that there's different types of signatures that you could throw at a problem like this to just see what happens. So yeah, that's my story of the time I wedged myself in sideways in the middle of people and their firmware updates. Thank you very much.